At Stray's Tutoring? Hey guys, welcome to today's video where we're diving into two key concepts in physics called scalars and vectors. They might sound a bit technical, but by the end of this video, we'll see just how much these ideas shape the world around us. So let's start with scalars. Scalars are quantities that are described only by a magnitude. This is a fancy way of saying simply a number or how much. There is no direction involved. Some examples are speed, temperature, mass, time. If I go back to our previous slide, we can see here some other ones: density, pressure, temperature. So let's go into a further example. We can say the car is going at 60 miles per hour. How much? 60 miles per hour. Not giving any type of specific direction, only how much. Temperature. What is the temperature outside? Well, it's 25 degrees Celsius. How much does this ball weigh? 5 kilograms. Time. How much time does it take for him to run? 10 seconds. So the key takeaways here is that scalars are the simplest forms of measurement, just the number and the unit. Notice how these examples don't tell you where something is happening, just how much of it is there. Next, we go into vectors. Vectors are quantities that have both a magnitude and a direction. So simply think of how much, or a number, plus the direction. This added layer of information makes vectors more complex, but also more powerful. So if we go back to our first slide, what are some examples? Displacement, velocity, acceleration, momentum, force, lift, and drag. And these are all different quantities that we're going to go over in later videos, but just kind of keep these things in your head, right? So an example is velocity, 5 meters per second, 5 meters to the east. Notice here how we have a number or magnitude plus a direction, east. Next we have force. 10 newtons is the number, and then the direction, or where, at 30-degree angle. Then we have 3 miles, which is the number, and then north, a direction. So you guys can see here where the vector has the number and a direction, right? So while speed is a scalar, for example, velocity is a vector because it tells us not just how fast you're going, but also in what direction. So the key takeaways here is vectors provide a fuller picture by including both size and direction. So let's go into a few practice problems, scalar or vector. If we're saying this car is going 60 miles per hour, is that a scalar or is that a vector? Well, this would be a scalar, right? This is a scalar because it only tells you how fast the car is going, 60 miles per hour. But now if we say 60 miles per hour north, this is considered a vector, more specifically velocity, right? 6 miles per hour north. This is a vector because it includes both speed and the direction that you or the car is heading. How about this one, 10 miles south? Same deal here. It's in miles, and then we're going south. So that would be a vector. Lastly, 200 kilograms, right? There's no direction here. It's only giving us the unit of measurement, the number. So this would also be a scalar. That makes sense to you guys? Remember, scalars only give you part of the story, while vectors give you the whole picture. So let's go into a real world example. Why are we learning this and what is it used in? So actually, it's really used in a lot of areas, aviation, navigation, sports. But for the sake of this video, we have the real world example of sports. When a soccer player kicks a ball, the force that they apply, a vector, determines how far and in what direction the ball travels. So we use this a lot in the real world. I'm not sure if a soccer player is actually calculating the vector, but if we were to actually look at it, it would actually be something pretty useful. I would say more specifically in aviation and navigation. In aviation, pilots use velocity and wind vectors to calculate flight paths, or in GPS systems, which rely on displacement vectors to guide you from one point to another. Okay? How are vectors represented? Well, they are typically represented as arrows, as you guys see down here. And the length of the arrow represents the magnitude. So we have 5 meters, and then we have 2 meters. So while the direction it points indicates the direction. So scalars and vectors might seem simple, but they're the building blocks of physics and engineering. Rockets wouldn't launch, planes wouldn't fly, and bridges wouldn't stand without understanding how forces, velocity, and directions interact. So scalars, again, they give us the what, while vectors give us the what and where. So now you know the difference between scalars and vectors and how they shape the world around us. The next time you're driving, playing sports, or even using GPS, remember you're interacting with these fundamental concepts of physics. If you guys enjoyed this video, please leave a like, subscribe, be sure to share, and I'll see you guys in the next one. Peace.